So welcome everyone. Looking forward to taking you through this training on battery management systems. We'll get started right at 10 o'clock. I'm joined here with my colleague, Chuck. We are in waterlogged California, where we have a brief break in the weather. Here it's not raining for the first time in seems like forever, I guess since the beginning of the year. And I think we're supposed to get a bunch more rain starting tomorrow, but I've got sunshine outside. What's the weather look like for you, Chuck?
Yeah, we're getting a welcome break. I saw some sunrise and blue skies for, like you said, the first time maybe this year.
Yeah, so I'm actually running this webinar out of a different location, just for fear that we might lose connectivity or power at my place. The power has gone out a few times, but I think we'll be good. And like I said, I'm looking forward to taking everybody through this training with us. It's 10 o'clock, so I'm going to go ahead and get started. Today's presentation is on why the battery management system matters and what a BMS really is. So that's what we're going to be getting into today. I'm going to start off by just mentioning to everybody again, my name is Nathan. I'm one of the trainers here at SimpliPhi Power. I'm joined with my colleague, Charles Holding, who's also a trainer here at SimpliPhi. And there are a couple of orders of business here or things to communicate to you at the beginning. If you want to ask us a question, please use the Q&A button that appears on your Zoom menu. We don't have the ability to unmute you, unfortunately, so raising your hand doesn't do much. We can't unmute you in this webinar format. But please use the Q&A. Chuck will be responding to some of those questions live as I'm going through the slides. And then if there are some residual questions at the end, we can address those then. Additionally, if you're here for NABCEP credits, this is a NABCEP certified course. Please stay through the entire training, and then we'll provide our email at the end, and you can send us your name as you would like it to appear on your NABCEP certificate. So if you want those NABCEP credits, you do have to stay for the entire presentation. We do check your participation. We're required to do so. So let's go ahead and get started. One more time, this is why the battery management system matters. So I will start this presentation with a brief overview of our company. SimpliPhi Power has been around for over a decade now, producing lithium iron phosphate batteries. And so these are batteries that are used typically for home backup, but there are a number of other applications that we've seen for our batteries. We basically have three main principles that we try to follow. One is safety. We want to have a very safe battery backup solution that is cobalt free. And so we avoid cobalt partly because the chemistry is less safe. There's a number of types of different lithium-ion battery chemistries, and we use lithium iron phosphate because it's one of the safest. It also avoids conflicts associated with cobalt mining. If you search cobalt mining, you'll find there are a lot of social and environmental reasons why you might not want to use cobalt-based chemistries. But safety is one of the biggest things. Lithium iron phosphate batteries really have no risk of unmitigated thermal runaway. So those lithium battery fires that you see are almost exclusively cobalt-based battery issues, right, associated with that chemistry. We have certifications, and we have gone through a number of different testing procedures. We're a heavily tested battery company, probably the most heavily tested battery company in the US. We're also very proven. We've been installing our batteries and providing our battery solutions for over a decade. Like I said, 12 years. We've been deployed in 45 countries. We have more than 250 megawatt hours installed worldwide. We've gone through testing with the Army and the Marine Corps. We also have permission to ship some of our batteries, qualified to ship to airship. So that's that UN 38.3 certification. So we've gone through safety testing to achieve that as well. And then another goal for our company is to be simple. It's to provide solutions that are easy to integrate into existing solar installs or existing backup power systems. And we try to make it as easy as possible for installers to use our products, basically to get critical backup, maximize people's energy independence, create resiliency in the energy market, energy security, etc. There are a lot of different reasons that people choose backup power, and we try to be a versatile player in the game. So this is a brief overview of the history of the company. Again, we started out as in 2010 as Optimized Energy Storage, and we've progressed through the years. We were acquired by Briggs & Stratton in 2021, and we've been leveraging their expertise to launch new products. One of them that we're very excited about is our new ESS. It was released late in 2022, and many people are installing these ESS systems now throughout the country and the world. And I'll tell you a little bit about that at the end. And we're likely going to have some promotions for our IQ installers geared towards installing the new ESS. So stay tuned for that. Again, like I said, our batteries have been installed across the world. This is our network of distributors, which is growing worldwide. So this is not a talk about chemistry. We have entire talks about chemistry and battery safety and different types of batteries. But I am going to start just briefly with an overview of what the internals of the batteries look like, because that relates to the battery management system. So again, there are lots of different types of battery chemistries. I've got 5 listed on the left side of the screen there. But there are other lithium-based chemistries as well. We're employing lithium iron phosphate. It's highlighted in green there for you. Form factor refers to how the individual cells that make up a battery are constructed. And so there are 3 different types. There are pouch cells, which are kind of the least durable but least expensive. These are low-cost options for lithium batteries, which are basically flat laminated layers of cathodes and anodes, which contain a jelly, which allows for the conductivity of the lithium ions. There are also prismatic cells, which are typically large, rigid plastic cased cells, which have some advantages and some disadvantages. Some disadvantages is that those large cells tend to build up heat more and are a little bit less durable due to the swelling and contracting that happens when batteries heat up, as they always do, when cells heat up as they always do as they charge and discharge. And then there are cylindrical cells, which are probably the most durable, but then the most expensive to use in terms of creating large batteries. These cylindrical cells, large numbers of these cylindrical cells, are used in the creation of our batteries. So because cylindrical cells are the most durable, they also offer better heat management. We use these cells in the construction of SimpliPhi products. So our form factor is cylindrical. Our chemistry is lithium iron phosphate. So how is a battery made? We offer 48-volt batteries, 24-volt batteries, and even high voltage battery stacks. Inside the battery are hundreds of individual lithium iron phosphate battery cells. And these have nominal voltage of 3.2 volts. So how do we make a 48-volt battery? First off, a nominal voltage is the voltage that a battery cell will have when it's at a 50% state of charge, right? So if I want a 48-volt battery, I would need to use 16 of these cells to create a 48-volt battery. And so our 48-volt batteries have 16 cells in series, but many cells are arranged in parallel. So the way it works is we have a number of cells arranged in parallel, and then we call that a stack, and we have 16 stacks of those arranged in series to get a 48-volt battery. So what occurs inside a battery is a series of, or a collection of cells in parallel and in series. We use high quality premium cells, which is why we're able to offer one of the best warranties in the business. We have 100% depth of discharge warranty that is that offers you 10 years, guaranteeing 80% of the original capacity after 10 years. So this helps us stand out as one of the highest quality batteries on the market. And one of the reasons for this is also our batteries have an incorporated high-end battery management system, and we have proprietary software that we've developed over the course of our life through research and development that we use to maintain the health of that battery. So what is a battery management system? That's what today's topic is all about. A battery management system is often referred to as the brain of a battery. It collects information about the performance of the battery, such as maybe temperature inside the battery, the amount of current. It monitors the amount of current. It monitors voltage on individual cells or individual parallel stacks inside the battery. It makes sure that those are balanced. And so it does a number of things, maybe even monitoring environmental conditions. And if it's an advanced BMS with communications, it also communicates the state of the battery out to other equipment. The main purpose of the BMS is really to protect the battery from damage and to keep that battery operating optimally. Most lead acid batteries didn't incorporate a BMS, right? Most lead acid batteries had were very simple designs, right? Which basically had a series of, so for a 6-volt battery, you can see there are 3 cells there on the right. They didn't need a BMS. And in fact, most of the health was maintained through the charging system, which was external to the battery, right? So if you've participated in installations where you're using deep cycle lead acid batteries, you typically would program the charger, and the charger would be there to try to maintain the health of the battery. You might have different cycles that would try to desulfonate the battery, etc. But there was no internal BMS in a lead acid battery. Especially with low voltage batteries, it was less necessary. As batteries have migrated to lithium batteries and higher voltage lithium batteries, typically, lead acid batteries were installed, with 12-volt units, and typically those units would not have any kind of balancing between the batteries. And so you could end up having some problems with putting too many 12-volt batteries in series. Lithium batteries are now, the default is kind of 48-volt for home backup, for battery backup. And so you have 16 cells in series. And so it's very necessary to maintain the balance between those stacks of cells inside the battery. It ensures that you get the full capacity of the battery. So by actively monitoring and adjusting the individual voltages of those stacks to make sure that the system is operating properly, we can ensure that we, one, get the longest lifetime out of the battery, but 2, also get that full capacity to be able to use it. It also protects the batteries from abuse. So one of the goals of the BMS is kind of the last stop as a fail-safe for protecting the battery. So if we put too high of a voltage on our BMS, it will open the circuit and protect that battery from damage. And it can also be there to help protect thermal runaway in the event that you had a thermal event, maybe the battery was dropped or punctured. The battery can open circuit and prevent more cells from discharging. So here's a simplified wiring diagram of a BMS. And this one, actually, I recognize this image. I didn't create this PowerPoint, but I recognize this image as I've seen this before on a BMS that I bought. I'm blanking on the name of it now. I guess I'm not going to be able to come up with it, but I recognize this image. So this is just a simple wiring diagram that shows you the negative terminal of the battery there. And then there's a connection between the negative terminal of the battery and the BMS. Now, large amounts of current can flow through these. So typically when you buy a BMS, you are buying a BMS that has a limit on amperage, and it also is referred to as a 5S or 4S or 16S. And what that means is the number of cells that are in series system. So this 12-volt system is a 4S system, and it would have a limit based on amperage. Large amounts of current actually have to pass through the BMS itself. And so you'll see fairly heavy connections if you look at a BMS. On the other side of that, the battery, so the two main connections are there for the contact and then for the battery negative, and that's the cell negative. So if you look at this particular unit, it also has 4 individual wires running between those stacks of cells. So this particular battery, what type of battery is this? How many in parallel and how many in series? This is a 2P4S battery because it's got 2 cells in parallel and 4 sets of those in series, so 2P4S. Well, for those sets that are in series, we have to keep them balanced because as current flows through these cells in series, right, the current through one set of cells is limited to the current through another. They all have the same current. But if the individual cells have slightly different capacities, the cells can be out of balance, and one set of cells could run out of current or run out of capacity before another. And so what a BMS does is it constantly tries to monitor and make sure all those cells are topped up at the end of the charging cycle. So we'll get into that a little bit later. So that's what those 4 wires at the bottom are for. And then at the top side of the cells of the stack there, you have a connection to the battery output terminal. This is a very simplified view of what a BMS looks like. And the BMS controls the circuits through a series of electrical components on a board. These BMS units are internal to almost all batteries and definitely to all of ours. So there are different types of battery management systems. The first type of battery management system is often referred to as an analog, but it's not really analog, it's really a non-programmable BMS. And the big difference between the two BMSs is one unit is programmable or programmable kind of after it comes out of the factory, but the analog units are programmed at the factory, and you cannot adjust those settings. So this is programmed during manufacturing. A very simple analog BMS might not have programming at all, and there are simple ways that you can maintain balancing across cells that are in series that I'll show you a little bit later. There are many integrated components on these boards, typically including things like either contactors to open and close, or field effect transistors, obviously resistors and diodes that are there. The performance is based on electrical signals coming from the individual components of the battery, but not from communication. So this is an analog unit, meaning it's not actively communicating with the other equipment in an energy storage system. And it relies on the values that are already on these components to have any action in terms of balancing and protecting the battery. Again, this analog system does not transmit data, so there's no communication built into it. It's not really transmitting information to other components of the battery or of the ESS system. A programmable or digital BMS typically has a user interface, and that user interface allows for settings to be adjusted, possibly even programmed in the field. It's programmable. It has a digital input, and it can convert that as well as electrical signals into taking action. So again, it's kind of the brain of the battery system. It's what allows us to monitor and adjust the behavior of the battery. It doesn't always have communication, so some digital systems may not communicate with external equipment, but they are programmable. And batteries with digital BMS also have analog components to help them function properly. There are also low voltage and high voltage systems. You can't simply take our standard Phi batteries and run them in series, right? If we were to take 3 simple Phi batteries and try to run them in series, the problem is that as you run batteries in series, the voltage would be distributed across them. So let's say that we took 2 24-volt batteries and put them in series to try to create a 48-volt battery. You would never want to do this, but if you did it, why wouldn't it work? Well, the BMS units are not designed to communicate with each other and to operate in a series function. Additionally, right, the voltage across one battery may be different from the voltage across the other battery. And so that BMS unit might sense a higher voltage and even open circuit. And if one battery in series open circuit, the other battery can't function. So we never use our BMS units, right, to connect our batteries in series. Our batteries are always connected in parallel. So please never use them in series. High voltage units allow us to connect high voltage batteries in series. And typically the high voltage BMS is referred to as a stack controller. It coordinates the readings from all of the batteries in a high voltage stack to make battery management system protection decisions, right? Stack controller hardware can handle very large voltages as well. And certainly the full stack voltage, our units go up to about 1200 volts for our high voltage batteries. If you aren't aware, SimpliPhi does have a whole high voltage and large projects division. Also, each battery within the stack doesn't have its own BMS built into it. The BMS is external for high voltage stacks. So why are battery management systems important? And what does a battery management system do? So as I said, to create a full high voltage battery out of 3.2 volt LFP cells, we have to run a lot of cells in series. And so passive cell balancing is done by having simple circuits. So again, this is an overtly simplified diagram of a way that we might balance the individual cells. So as you can see in that diagram, one of those cells is completely full. And so if that cell is completely full, that charging source would not allow current to pass through that individual cell, and the other cells would therefore not be able to charge. But if that cell has the switch closed so that some dissipation of electricity or some dissipation of heat can flow out of that resistor, electricity can flow around that cell and top up the other battery cells. So again, this is overly simplified. As you saw from the integrated circuit board, this is not, an accurate representation of the circuit of a BMS, but this is essentially what a BMS is allowing to happen. A active balancing in a slightly more advanced BMS is when a battery management system pulls power from one cell and uses it to charge other cells. And again, I have an overly simplified diagram on the right side here. And what you can see is individual capacitors can be connected across the battery cells, and those switches can be controlled from the BMS to charge up the capacitors and discharge those across other cells. The balancing typically occurs at the top of a charging cycle. And this is great. So it's more important to have this active balancing. It becomes more and more important as the battery cells themselves age. So when a battery is first manufactured, most cells will have the same capacities within just a few percent. But as individual battery cells of a battery age, their capacities vary slightly with time. And that happens for many different reasons. It happens if the cell is potentially abused. It also can just happen naturally where the lithium that's inside the cell can plate out a little bit. And so if you look at almost any battery after a long time, there will be greater variations in the capacities than when first manufactured. So as a battery ages, you get a lot more lifetime if you have an active cell balancing BMS and a BMS that is good quality to keep the system functioning well, even when you have slight differences in the individual cell capacities. Other battery management systems, so some of our battery management systems have protection through closed loop communication. So again, the main function of a BMS is to keep a system working properly, as well as to protect the battery itself. And what closed loop communications allow a BMS to do is, as the BMS is monitoring the currents, voltages, even temperatures inside the battery stacks, it can provide that information It can provide those voltages, those capacities, even state of charge, state of health, etc., to the charging equipment, or even the discharging equipment, the inverter, the loads, to limit the amount of power that comes out of the battery. So the battery can communicate with systems, and typically this communication is done with CAN bus. And we have several units that offer, we have several different batteries that offer these more advanced comms BMS units. How are the BMS units programmed? So all of the BMS units inside our batteries come with software, and this software is can receive updates. The software for some of our systems can be programmed remotely. It can also provide data out to different types of systems to monitor. So we do sell gateways with our SimpliPhi and our SimpliPhi battery systems that can tell you all sorts of information about what's going on inside the battery. It's not necessary for some installs, but for other installs, it can be very useful to have this information. Some of the most important settings, of course, are not done with the battery management system, but are done on the equipment outside. So it's very important, even though these systems have battery management systems, it's very important that the equipment that's operating with Phi batteries with analog BMS units be programmed properly. So that means setting the low battery cutout voltage properly for our batteries at 48 volts if you're doing 100% depth of discharge. It's also very important to set the charging cycle voltages, right? And we have integration guides, and we have other documentation explaining to you how to do this. It's also important to make sure that the charging current is set properly so that you're charging your batteries and discharging them at a rate of C/2. So again, just because a battery has a battery management system does not mean, right, that you don't have to set the rest of the equipment up properly. Our SimpliPhi batteries and our newer SimpliPhi wall mount 4.9 kilowatt hour batteries have closed loop communications. And this allows the individual computers inside the batteries, the BMS units, to communicate with each other, as well as to communicate with other equipment, such as our inverter or a solar inverter, etc. The BMS can automatically communicate the size of the bank, because it knows when the BMS unit is connected to other units, right? It knows how many units are in parallel. It knows the state of health. It knows the temperature across those 16 stacks of cells. And so a lot of information is sent through these closed loop communications. And so if you're building a larger system, we highly recommend that you use a system that has closed loop communications. It's also important for some people to be able to monitor their systems remotely. And so if you're using our SimpliPhi or our SimpliPhi batteries, you can see how their performance looks in real time by utilizing one of our gateways or somebody else's system that communicates with our batteries, like our solar inverters that we sell. Our Phi batteries come with a simpler analog BMS system, right? We don't adjust the programming on these units after manufacture, and it does not have closed loop communications capabilities. That doesn't mean it's not as good of a BMS or not as good of a battery. In some cases, like maybe lead acid replacement, right? You're using older equipment, you want to save some money for the customer, you want to save some money on the install, and an analog system will work fine. We have a huge number of our Phi batteries operating out there in the field that have been out there for a long time, right? 10 or more years. And these batteries are operating just fine off of analog communication systems or analog BMS unit. This is a picture of our SimpliPhi batteries. The big difference between the Phi battery and the SimpliPhi is simply having that closed loop communications. This allows the battery, when properly connected with an inverter, to automatically communicate all of the set points that are necessary, all the set points that the battery wants, It also provides high voltage protection. So for this particular battery, if the BMS sees a voltage of above 58 volts, it will automatically open circuit and turn the battery off, open a contactor to prevent damage to the cells. It gives high level accurate readings, so much more accurate readings than the inverter or any kind of charging device on state of charge, voltage, charge and discharge rates, health, etc. And this is flexible. We can connect up to 72 of these batteries in parallel, and all these batteries can be communicating with each other as well as inverters. This is an example of one of our high voltage units. Like I said, high voltage units are typically what is used on large scale projects. They're also slightly more efficient in terms of delivering energy and power, but typically don't come in small sizes. So our high voltage product range can provide solutions from 200 volts all the way up to 1180, and we can provide very large containerized solutions for big projects. So we typically will have projects for like agricultural or oil rigs have asked us to do containerized solutions, and these will often involve high voltage batteries with stack controllers. Each individual battery is connected to the stack controller, and the stack controllers are independent units. The cell interface may be either internal or external, but typically the contact is external, and the stack controller is mounted on the top. If you have questions about high voltage solutions, we're also happy to put you in touch with our engineers in the high voltage division. So choosing the right product, what product is right for you? So as I was saying, you know, several of our battery solutions, the 5 batteries, right, don't have closed loop communications, but they're actually an excellent choice for things like lead acid replacements or older equipment. When you're using a grid tied system and you want monitoring, that's when the advanced communication system is more helpful. It gives you so much more information. It also provides more information for protection of the system by allowing communication to components like charge controllers and inverters. It also allows for remote monitoring. I want to point out a few things off of our website for you. Today's presentation is fairly short, but I want you to use our website as a resource as well. And so a lot of times we'll get calls in on tech support to our company asking us questions or asking us how to do a particular installation. And it seems that many people aren't aware that we have integration guides, installation manuals, and how-to videos on our website. The integration guides are written by us to tell you how to use our product with other people's equipment. So for instance, you might be using Outback equipment and want to know how to set up that Outback equipment to properly utilize our 5 batteries, for instance, what those set points are, etc. If you click on the integration guides here, it will take you to a section of the website where we tell you the specific set points. We show you screenshots of what it looks like on the Outback's software and ways to program them. The installation manuals, of course, if you're using our equipment exclusively, right, we have an installation manual for all of our equipment there. I also want to highlight to you that there are more trainings on our website, and you can find the calendar for those trainings by clicking on this link here. You can also click at the link at the very top of the screen to see other trainings that we have coming up, such as battery chemistry or battery 101, or 9540 certifications or safety, etc. Another thing that I want to recommend to you, and I've kind of highlighted on the screen here, is when you do finish a project, whether for yourself or somebody else, click on the warranty registration link in the bottom left of the corner and register that product with us so that you have that warranty there. Additionally, we have an IQ installer program that's an installer qualification program, and our IQ installers get special perks. And as I was mentioning at the beginning of this call, we have some promotions that are going to be coming up. I also want to highlight other ways that you can learn about our batteries and our battery solutions. We are part of Briggs & Stratton. Briggs & Stratton has a large selection of home backup generators, and there are trainings on this website associated with those and how to integrate those into other backup systems such as solar and battery-based systems that SimpliPhi has been selling. So I will be sending a copy of this presentation to everybody who's here, and you'll get a link to this website. So if you're interested in signing up and using the Power Portal to learn more, you'll have that link. I also want to highlight to you that Elite IQ program. That's our installer qualification program. We're going to have some big promotions coming up for installing your first system as an IQ installer. So keep tuned for that. We're having very large amounts for that. Also, if you are installing our batteries currently and you sign up to be an IQ installer, you get $25 cash back for every battery that you install. So if you install 20 batteries in January, we'll send you a check for $500 for that. We also have a photo contest for our IQ installers. The other benefit of becoming an IQ installer is we put you on our map, and we recommend your business for people to buy our batteries from / install our batteries. And as I said, we're going to have some very big promotions coming up for installing our new ESS system. And this ESS system is a hybrid inverter that can be used in just about any configuration. And so stay tuned for that as well. So if you were here and are wanting NABCEP credits, please send us an email to training@simpliphipower.com, and we'll issue your NABCEP certificates. If you have questions on designing or sizing or purchasing equipment, contact our sales engineers, and the phone number is displayed there, 805-640-6700, and choose option number 2. So with that, I think we can move into the Q&As. Chuck, do we have any outstanding questions? It looks like
we have a couple, yeah. Answered a couple during the presentation, and a couple came in just real recently. Ed asks, are there different faults that require different ways to reset the BMS?
Yeah, I think that's a good question, Ed. There are, in some circumstances, there are events that can lead, like for instance, a very high voltage that can lead to either damage to a BMS, or it can lead to a manual reset necessary. These are uncommon. Most often the BMS can simply be reset by turning the battery breaker off and on. But if there's been damage inside, or if there is a particular event that needs more servicing, it would need to be sent in. But like I said, most of the time, the BMS, like for instance, an over voltage can be reset simply by turning the battery on and off. Kuno writes, I have installed several of your batteries in the past, but never registered the warranty. Can I do that for installs from a couple of years ago? What would I need for that? Good question, Kuno. Yeah, even though we still honor the warranty, whether or not, as long as you can provide proof of purchase, whether or not you've submitted the warranty registration. One of the benefits to submitting the warranty registration is that if you're an IQ installer, that's the process that you use to get battery rebates. But yes, if you need them from 2 years ago, what you'll need is system information. So number of batteries, what equipment was being used, and serial numbers. And you can access that information, a list of that information, simply by clicking on that warranty registration link. Are there any other questions? That $25 per battery rebate is for the installer or the customer? That's for the installer, so that's for IQ installers. And additionally, that we're going to have, like I said, some big promotions coming out in terms of large cash back amounts for the first SimpliPhi system that you install. And then if you're already an IQ installer, we're going to have another promotion coming out for installing your first ESS system, which would be utilizing our inverter. what charger to use if battery reaches zero. So if you have a battery that is been run down for maybe some reason, like the system wasn't hooked up right, or something that's caused a battery to reach a very low voltage, we recommend, I'm blanking on the name, Chuck, what's the name of the charger that we recommend?
I don't know how to pronounce it. I think it's called WAUKS. WAOUKS. There's a couple of them on Amazon.
It's also linked in our manual as well. So if you download our manual and need an external charger like that plugs into 120 volts, and you click on the Phi battery manual, there is a link in there for the one that we recommend. So thank you, Chuck.
Yep. Peter also asks, how long can a battery sit at zero before damage occurs? How long can a battery sit at 20%?
So that's a good question, and it really depends on the conditions as well. So typically, especially with analog BMS units, because there's no communications in there, if the battery is switched off, the battery only discharges at a rate about 1% per month. We do recommend topping up the battery every 6 months. But to give you an example, I was speaking with a colleague who had a system that had been fully charged but left to sit in Florida for 1.5 years, and he went to check the system while I was there, and it was still at 94% state of charge. So as long as they're switched off, the batteries can sit at low states of charge for longer periods of time. Are there any other questions? Yes, go ahead, Daniel.
No more questions, or one just came in, but I think it's also worth mentioning, like Nathan said, if the battery breaker's turned off, because oftentimes if your battery is connected to an inverter, that inverter may still be active and drawing some power, even if it's not providing to loads. So a low state of charge may be detrimental. If you leave it connected to the inverter, it can continue to discharge over time at a rate much higher than what Nathan was saying.
Right, and the other thing to point out is if you leave one of our batteries with communications on for longer periods of time, the BMS itself also utilizes some energy, right? So as long as the batteries sit switched off, then the BMS will power down and the battery can sit for longer periods of time. Jim asked, what types of issues are being experienced with the batteries that have communications, and with which supporting equipment? We've installed 5 batteries on a few systems without back. A customer had to have the Discover lithium battery, and the only equipment at that time to work with it was Snyder. Many issues that I attribute to or related to communication/operation of these batteries, extremely time consuming to resolve. That's a good point, Jim. So the battery management system is basically a computer, and that computer for these COM batteries has to be able to talk with the computer on the inverter or the charge controller, right? So if you want to use one of our units with BMS, that has communications, we have a recommended list of inverters to use. We recommend Solarc inverters. We recommend our own inverter. So our own inverter talks well, obviously, with our software. And then we have one other inverter that we have been on the list, but I'm not even going to mention it right now because we've been having some problems with that company. And so I would recommend, if you want to use a battery with communications, one of our batteries with communications, you either use a Solarc, which talks nicely with our software, or you use our inverter. And again, there's going to be great opportunities to use our inverter in the future. And if you're an installer, you'll be able to get a large amount back for doing so. So stay tuned for that promotion that's coming up. All right, so I want to thank you all for your attendance today. I appreciate the questions. This was not a very in-depth training, but we have a large amount of other trainings on different topics. And so if there are questions that weren't answered, look at our upcoming training list. And again, if you're here for NABCEP credits, please email me, training@simpliphipower.com. Thank you for your attendance, everybody.